Hello and welcome to this tutorial. I'm going to start a series of tutorials on statics, which is one of the most important parts of engineering fields at university. In the most of the resources of statics, they start with the topic of vectors. So I'm going to start with vectors, which will be the subject of upcoming tutorials. I will go through different types of vectors, addition, subtraction, and at the end I will solve some problems to see the application of vectors practically. So at the beginning, I would like to define the vector quantities. The best definition of vectors can be obtained from the difference between the scalar quantities and vector quantities. So basically, we have two types of quantities in physics. The first one is scalar quantities, and the second one is vector quantities. The scalar quantities are those having only magnitude. There is no need to be an engineer or expert to deal with scalar quantities. Everyone in daily life has a relation with scalar quantities. For instance, you go to grocery and buy 2 kilograms of apple, or you measure the height or length of a table and write down the dimension like 1.5 meters. You see the temperature on the screen like 22 degrees C. All of these numbers are magnitudes with corresponding units. Although if you change the units and you go from one unit system to the other one, the numbers will vary. But at the end of the day, all of them are scalar quantities which have only magnitude. When it comes to vectors, the vector quantities have both magnitude and direction. So this is the point that distinguishes the vector quantities from scalar ones. The most common and famous vector quantities in physics are force, velocity, acceleration, and displacement. Since we focus on statics during these tutorials, the main vector quantity will be force. Velocity, acceleration, and displacement are studied in the other branch of physics under dynamics, and if I want to say more specifically, it is called kinematics. Now we have the definition of vector quantities based on the difference between them and scalar ones. Now let's see the characteristics of vectors. As it was mentioned, vectors have both magnitude and direction. So vectors can be sketched on 2D or 3D planes. But in these tutorials, we will mostly focus on 2D vectors. So vector is illustrated like an arrow. Usually the magnitude of a vector is written beside this arrow and a small arrow on top of the symbol or magnitude indicates that this is a vector. Every vector has an initial point, which is called the tail of the vector, and also the arrow part is called the tip of vector. Every vector on 2D plane behaves like a line segment. So let's go through a 2D plane like this with x and y axis. If you remember from high school, a line segment on the 2D plane has a length like L. To find the length of L, we have to know the coordinates of these 2 points that I call them L1 and L2. So if L1 contains x1 and y1 like this, and L2 includes x2 and y2 as the x and y coordinates on the 2D plane, the length of L can be obtained using the Pythagorean theorem, which is the square root of x2 minus x1 power 2 plus y2 minus y1 power 2. So basically these 2 brackets inside the square root covers these dimensions. This recall is necessary to be understood because, as I said, vectors behave like line segments on 2D planes. So if we consider a vector like V, vector V is composed of 2 scalar components on the 2D plane, which I named them Vxi plus Vyj. So here I and j are the symbols of vectors, or in some resources they are called the unit vector components that indicate the components corresponding to x and y axis belong to vector V. So let's sketch this vector V on a 2D plane. Again, x and y axis, and this is vector V with certain coordinates So this is Vy and this is Vx and this is V. To find the magnitude of V, which is usually written in this way inside the absolute symbol, the same formula is utilized. The square root of Vx power 2 plus Vy power 2. So I can obtain the magnitude of the vector V using this formula. So if you are given the scalar components of a vector and then asked to find the magnitude, this is the formula for 2D vectors. So now we understood the definition of vectors and how they behave on 2D planes. In the next tutorial, I will introduce the addition of vector and their laws.